Okay, welcome back, ladies and gentlemen. We are doing trig graphing, and I was gone yesterday at a sub, so there's no video for that. Pretty difficult to get myself to record every day, much less to get the sub to record when I'm gone. So I will do a little summary of yesterday, and then we'll do a review problem on it. So yesterday, I hope you got into some ones that had a little bit more going on. Like, here's the general format. Where that is the amplitude, and it's usually a number like 2. This has to do with a stretch or a shrink, depending on what the number is. This is how far it's moved right or left. And this is how far it's moved up or down. So if you were asked to graph this on the test, I hope you'd be able to tell me, okay, I know it's a wave. That much I know for sure. Do you know what the parent graph looks like? You got to start with that. If you can't graph the parent, then you can't graph this. All right, so let's start with just, would you please graph the parent for me right now? I'm going to be coming around to make sure you guys know how to do this. And the 4 important spots, other than 0, which I hope is obvious, are, I actually like to start with the end. Because if you're doing sine, you're going to end at 2 pi. Granted, we'll be changing this later, because this stretch will make that different. Okay, so this 2 pi here is how it ends. And then you can go back and say, what's halfway there? This is a great way to do it. Say halfway, see we're halfway to the end. Halfway back would have been 1 pi. And then half of that would be pi over 2. Now what that breaks down on is it doesn't tell you that third one. So then what I like to do is to think it through, is go, this was 1 pi over 2. This was like 2 pi over 2, right? Because that simplifies to pi. That logically means this must be 3 pi over 2. And the last one is 4 pi over 2. And why is that especially good? What if you had to shift this whole thing over 1 notch? People often don't know what to call that spot right there. And if you use this technique I just showed you, 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 is the same as 2 pi, then you can't help but say the right thing there, which is 5 pi over 2. Get what I'm saying? Why would you ever care about this spot? Because you're going to probably be shifting. You'll have this wave, and they'll say, take this wave and shift it pi over 2. And so you're going to say, well, okay, so pi over 2 is like this far, so I will shift it that far. And then naming this spot is hard for a lot of kids. Trying to give you a strategy there. Count by the first unit. If it starts with 1 pi over 2 at the beginning, then count everything as pi over 2s. 1 pi over 2, 2 pi over 2, 3 pi over 2, etc. All right. So now, this one is, I don't need to shift this one. So I'm going to actually undo some stuff I just did there. But I wanted to show you why we would like to count by pi over 2s. All right. And then sine, you need to know it starts at 0, and it basically does that. Now, that is not a perfect graph, but you know what? I wouldn't even mark that wrong on a test. It's a little bit, you know, not exact, but if this was labeled with 1 and this is labeled with a -1, I'm not going to be that fussy that, ooh, it wasn't exactly symmetrical. Okay, now what do I need to do to it? That 1/2 right there. What does that change? Well, you could just say it changes the amplitude. True. But on this graph, what should I change? Because there's a 1/2 here. A little more participation would be good because it's going really slow. Okay, yeah, the minimum and maximum. Good. That spot and that spot. Or you could have said things on the y-axis need to change. Okay? All right, instead of me just talking about it, maybe you aren't going to do it if I just talk about it. I'd like you to not do this whole thing because that's just a little too much. Okay? This is doable. You should be able to know how to renumber for that. And then this shifting by the minus, the shifting by pi, that's starting to stretch a little bit. But I think with yesterday, they started to tell you about how to shift. Well, the biggest question there is kids will ask, how do I know how far that is? Well, once you've got it renumbered, you know, this 3 here is going to make you renumber this. Once you've got it renumbered on here, and all these are different, you look for where pi is. And if you realize that this is the spot where pi has become, you know what I mean, after you've renumbered it, let's say pi is there, then that's how far pi is from 0 to that spot. And that's how far you should shift it. So in this case, it's got a minus that, so that means I'm going to move to the right pi, and you got to figure out where pi is after you've renumbered things with that 3. All right, so this is tough stuff. I want you to somebody work with. So right now, I'd like you to, this is a smallish class today, just find somebody hopefully nearby you that you can work with. I want groups of 2. Go. Okay, welcome back. So just a quick, some observations. Hopefully you learned something, or you at least practiced something. This 3 has the effect of, think about it, should it be multiplying everything by 3? No, because you're on the inside. Remember, you don't trust the inside. Seems like you multiply by 3, so you don't. You multiply by 1/3, where you divide everything by 3. But I like to think of it as multiplying everything by 1/3. So I'm going to take a little 1/3 here, and then multiply it here, and here, and here, and here. And then my new answers will be 2 pi times 1/3 is 2 pi over 3. 3 pi times the 1/3 will make it 3 pi over 6. That's also known as pi over 2. This pi becomes pi over 3. And this pi becomes 1/3 here, pi over 6. So you remember me saying how to figure out where pi is so that you can figure out how far to move it? Well, pi isn't one of my choices. It's not even on here. That's why I was telling you, you need to know how to count by these. So if this now is 1/6, do you get how I got that? It was pi over 2 times 1/3 made pi over 6. Are you reading me on that one? You get how that's pi over 6? Okay, if that's 1 pi over 6, then the next one's 2 pi over 6. You get how that could be considered 2 pi over 6? Just when you reduce it, it becomes pi over 3. So that's 1 pi over 6, 2 pi over 6. I think you see where I'm going with this, right? 3 pi over 6, 4 pi over 6. What would be the next mark? 5 pi over 6. What would be the next mark after that? 6 pi over 6. That's where pi is, way the heck over there. See what I did there? I figured out what mark was pi. So now I know that in my graph, it took me 1, 2, 3, 4, 5, 6 marks because they were all pi over 6s. How do I know that? Because this one was pi over 6. So they're all 1/6 of pi. So of course it took 6 pi over 6s until I got to pi. So that's how far you shift it over. There we go. Now, if you want to, you could extend this graph and then see, where does 6 pi over 6 kick in? That was right here. And so, oh, there we go. And then my graph starts there at 6 pi over 6. Anyway, I think it's the easiest for you to just take this original graph right here and move him over. How far? Pi. It says right here to move it pi to the right. So then where is pi? It's over there. So now I moved it over pi to the right. All right, that's the hardest stuff. That's the toughest stuff you'll have to handle in graphing on the test is shifting. All right, let's talk over one, actually, yeah, so one more like that because I'm not sensing like everybody had that. So let's try a different one that's similar. Okay, y equals 4 cosine, that'll make you graph a different parent, of 1/2 x minus pi over 2. There. That's got as much as we could possibly do to you on a test. It's got the amplitude change in the front, which is the easy part. And then it's got this, which makes you renumber everything. And then last but not least, it's got a shift here. After you've done the numbering, then you look and see, how far should I move this thing now? How far should I shift it to the right? And again, I totally will accept an answer where your graph has been shifted like this, as long as you have it labeled. You know, you got all these spots labeled here, and I'm fine with it going over. I know everybody seems to like to want to have their graph start right at 0, 0. You don't have to. Once you got it shifted, if it ends up being over here, that's fine, as long as everything's labeled. How we grade these is it in the right place, and are those the labels in between the x and y axis labels, are those right? Okay, give that one a shot, and remember, you're graphing cosine this time, not sine. So start by graphing parent cosine. Always start by graphing the parents. It's so much easier than trying to do it some other way. All right, I'm going to pause while we give that a try. Okay, let's see how you did. First of all, did you know cosine started at 1 and then kind of is like a big valley? Okay. Hope you know that. That'll help on the test. We don't just test on sine, even though sine is the parent of them all. All right. So then, what are the key marks? Well, there's one here, there's one here, there's one here, and there's one here. And that's 2 pi. And then that's the way I always do it. I start with the end. And then I go back and go halfway and say that's pi, and then half of that, pi over 2. And then, if you want, another great way would be to count it up from the beginning. 1 pi over 2, 2 pi over 2. That must be 3 pi over 2, and that's 4 pi over 2. Okay. So there's the parent graph. What am I missing? There's something important, because you have to label more the y-axis labels. Because you're not exactly chatty with your teacher anyway. All right. More participation would be good. I know it's Friday. I know you're tired. It's been a long week for a lot of us. All right. So anyway, if we have to do this 4, that's the easiest thing of them all. That 4 is just change that to a 4 and that to a negative 4. Granted, in the real world, if you actually looked at this graph on the same axes, it would be stretched 4 times as high and low and stuff. But you don't have to do that. You just have to change your labels. Cool. So the 4 is done. And that was called the, it's got an A word. What is it? Amplitude. Okay. Next up, that's called B. And the B term is a 1/2. Seems like we should cut all our numbers in half. So don't cut them in half, because you don't trust the stuff on the inside. You multiply everything by 2. So that became times 2, times 2, times 2, and times 2. And the 2's happen to cancel each other out really nicely in a lot of places. So that's pi. That's 2 pi. That cancel is 3 pi. And that one's 4 pi. Yay, it's just counting by pi's. So then, if we're counting by pi's, if this new spot here is just pi, I hope you know where half of a pi is. Why do I care? Because it says on the second part here that I have to shift it right half of a pi. Well, that would be, I'm going to put a dotted line right there, halfway to pi. Because this is pi now, right? Okay, so I'm going to shift it over that far. There. I'm done. Okay. That's the end of that part. What else do you have to know before you get tested on this graphing test? Basically, you know, Dancer and Prancer and Connor and Vixen. Anyway, You know sine and cosine and tangent, but do you know cosecant, secant, cotangent? Oh, you have to learn all of those too. All right. So now you got the, really, honestly, that's the hard part. It's just moving a different shape now. You got how to stretch them. You got how to move them. Okay. But what if they're a different shape to start with? Well, the sines and the cosines are waves. And remember how they all have sister functions? Sine goes with cosecant. Remember that list? Let's do it again. Sine, cosine, tangent. And then to the right of sine, leave some room here because we're going to make sketches. Cosecant, secant, and cotangent. I am going to sketch for you the rest of them. We've done a lot with sine and cosine, and rightfully so, because I'd say at least 3/4 of the test would be on sine and cosine, because they're the main ones. Okay, but what about the offshoot ones like tangent? Do you remember that tangent had asymptotes at pi over 2 and negative pi over 2? And it went like this. That's the parent for tangent. Got to have that one memorized. I'm not going to reiterate sine and cosine. We just did both for quite a while. So, and in a way, I will be when I'm doing cosecant. I'm going to be doing sine again. Remember how they're sister functions, so they're related, right? So if I start by graphing sine, do you remember that cosecant is actually 1 over that? And that's not a problem unless it's 1 over 0. So wherever sine hits 0, which is here and here and here, what would happen if you're doing 1 over that? 1 over 0, which would be what? Undefined. It can't happen. So at those moments, our cosecant graph has asymptotes because it can't work there. And then, what the rest of the graph looks like, remember, sine is the blue one. This is not sine. This is its sister function. But it helps me a lot in drawing its sister function. Remember that whole thing where when the one graph got really small, the other graph had to be getting really big? Remember doing those? Those were reciprocal functions. It was very similar because these are reciprocals of each other. So they're loops, and they like to ride on the back of the sister function. And this is a little 1 and a negative 1. And why are those important? Because when you put 1 over 1, you get 1. And when you put 1 over negative 1, you get negative 1. So these are the only spots, there and there, where they touch. And then, since this is supposed to be about cosecant, I'm pulling this one out. And what I have left there, these were just some little helper dots that were reminding me as the one function got really small, the other one would get really big. So I'm going to delete those. Here's your answer. Cosecant. It looks kind of like little parabolas. But you know how you make it? You always make the sister function first, and then you draw loops on its back, and you put in the asymptotes where the function hits 0. And it's going to be the same exact thing for secant, because it's a wave just like cosecant. I just start by graphing cosine. Here's cosine, starts at 1. And then, what was special about these spots? At those spots, you got dotted lines, asymptotes. Because why? Because 1 over that 0, 1 over 0 can't exist. So there's asymptotes there. And then, same idea, it's riding on the back. Sort of like riding on the back of a sea snake. Now, why did I make those little loops that way? Well, they technically go like this, but I don't need all of them. In fact, if I did this, do you get I would have actually graphed more than just one set. I'd have two upper loops and one lower loop, and that doesn't have symmetry. If I want it to have symmetry, I'll take those off from there. In the big picture, in the long run, it would kind of look like this. Cosine will be doing this, and secant will be these little loops riding on its back. And there'll be asymptotes whenever the blue line hits 0. Asymptotes there, 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 etc. And the sister function is just in there to help us draw the actual function. The actual graph would be just the green ones there, just a bunch of loops. So I don't want you to think when I drew it here that this one somehow looks totally different than the other ones. No, it's just a whole bunch of loops. It's just that those loops, I wanted to only have equal amount of upper loops and lower loops, so I cut off some. It's not that big of a deal. If I put them back in here, you would lose partial credit though, because the directions on the test are going to say graph one period of, in this case, secant. And do you get how I did two upper loops and one lower loop, and that means I did more than one period? So you don't want to do it that way. You want to cut off the other edges there and say, there's your parent secant graph. And again, this is riding on the back of its sister function, which was cosine. Getting that out of there. Don't need that either. And then last, because I want you to have them all in one place, the last one is cotangent. That one's not one of those where it rides in the back of its sister function. You just got to look at this one as a different thing. Cotangent is the inverse of tangent. And as such, you can't just say, oh, it flips like this, even though it's kind of like that. It is similar to that. That's kind of what an inverse does. But remember, when it hits 0, it has to have an asymptote. Same idea there. So all of a sudden, the asymptotes are going to move. That's the pain in the butt part about cotangent. Everybody thinks cotangent is exactly the same as tangent, just looks like this. That's wrong. Because remember, tangent, I'm going back to the original tangent graph here, it's hitting 0 right here. That means when you do 1 over that, it has to have an asymptote right there. So there has to be an asymptote here, so it can't have its graph right there. So when it gets off of 0 and it's really close to 0, I'm saying that badly, but in this area, it's really high because the other one was really low. So 2 asymptotes for cotangent, and the graph does kind of look like this. It's going the opposite direction. As you read from left to right, it's falling the whole time. And its period, just like tangent, it has a period of pi. See, this has half a pi in this direction and half a pi in that direction, means the whole thing gets done over the course of 1 whole pi. This has a distance of 1 pi also, so that's pi. And then what would be halfway? Pi over 2. And then, of course, that's 0. So it's going to take that all together. I'll rewrite them. Pi over 2 pi. And the blue equation is cotangent. Now, you have learned pretty close to everything you need for your next test. So if you feel like you don't understand everything I just said, that's okay, because we still have several days before your next test. It is happening next week before we head off for spring break. But you have time to absorb all of this. But I needed to tell you what all of the functions were today. So now you know if they say graph secant First thing you'll do is not graph secant. You'll actually graph its sister. So you got to think, what's the sister of secant? What is sister of secant? Cosine. So then you graph your cosine, and then you make the whole deal where it rides on the back of the sea snake. And then, whenever the sea snake hits 0, asymptotes. If I wanted to continue a little bit more, now I did not do 1 period. It's got 2 ups and 1 down. I could even finish and get 2 periods. There, I just graphed 2 periods of secant. The green one is secant. The black one is cosine. So I can really pull the black one out, and there, I've graphed 2 periods of secant. But what if they said 2 secant? Then, wherever 1 used to be, which was right here, you know, this used to be 1, and this used to be -1. Well, what are they now? 2 and -2. And these things that used to be pi over 2 and pi, etc., etc., I can renumber those based on if I want to put like a 7 in there. I multiply everything by 1/7, just like before. I'm going to put my cosine back in here so you can see. It used to end right there, was 2 pi. And that was pi. And that was pi over 2. And this is 3 pi over 2. And if I put a, we're not going to put a 7 because we always use even numbers. Because you don't ever have 7 pi. Anyway, put an 8 there though, I could see that. Or a 6, or a 4, or a 2. Divide everything by 8, or times by 1/8. All right. Let me give you some homework to chew on. I'm going to pause for a second when we find that. All right, so here's what we have found is a good spot for today's homework. This is from lesson 14.1, day 2. And it's a lot like what we did before, except it does some with tangent. So I am going to say, let's do 14, but not 15. Skip 15. Let's do 23. Is there any more on that page? My computer's freaking out. I can't move anything. Hold on. Nope, not doing that one. So I am changing my mind. We are going to do 15, but that's all we're doing. 14, 15, and 23. Those 3. I'd love to do one with cosecant. I'm gonna pause and see if I can find any that I have the solution. Okay, I apologize. I'm changing my mind again. We are going to skip 15, but I'm going to give you one to do instead, and I'll make it really simple. Instead of tangent here, scribble out the tangent and put in secant. So that means you're going to start by graphing the parent function, which one goes with secant? Cosine. You'll start with cosine, and then you make it right in the back of cosine. And also, it's got a little too much going on here, so we're going to scribble out the +1. at the end. And last but not least, on the inside, I want to factor that for you. Even though I know you know how to factor, you might not think to do it. On the inside there, if I take out a -2, what would be left on the inside? X minus, no, not pi. It would be x plus pi what? Yes. Because then when the 2 multiplies in there, it turns into what it's supposed to, which is a pi. That was some pretty tricky factoring. Now, one last thing. I don't feel like this is also doable because of the negative here, so we're going to change this to a positive. Okay, so that's just 2, not a -2. We're scribbling this out. I know you have totally changed the question, but at least you got a graph upon which to do it. And I think your total number of questions is very reasonable. Get those 3 done. And then, as I told you, my target is 2 assignments per week from here on out to go in the grade book. So that means I'll probably hit Monday with grading these. So be ready. And I know you don't have the key for number 15 because I just made it. So deal with it. You have one that you don't have an answer key for. You'll live. Normally in past math classes, I told you I had every single answer to every single problem. So I think you'll live with one question like that. Okay. So again, the new question here was secant of 2 parentheses x plus pi over 2. And secant rides on the back of cosine, so you would start by graphing cosine. I personally would make it like start every 4 marks is like your 1, so to speak. But you don't have to do it that way. It's just going to be a little easier and cleaner. Okay, that's all I got for you for today.